So hi, in this video we'll be discussing question 1 of AS A-Level Mathematics, paper 1 of 2015 summer session. So in the first question it says that given that theta is an obtuse angle measured in radians and that sine theta is equal to k, find in terms of k an expression for cosine theta. This question will be a little bit difficult because theta is an obtuse angle. That means that the angle will be between 90 degrees to 180 degrees, and it makes difference to the sides. So let's first draw a quadrant so you can see for sine, cosine and tan the signs that they have to be. So between 0 degrees, 90 degrees, 180 degrees and 270 degrees and back to 360. Between 0 to 90 degrees, if theta is between 0 to 90 degrees, sine theta will be positive, cosine will also be positive, and tan will also be positive. Between 90 degrees to 180 degrees, sine will still be positive, cosine will be negative, and tan will also be negative. When the theta is between 180 to 270 degrees, sine will be negative, cosine will be negative, but tan will now be back to positive. And from 270 to 360 degrees, sine will still be negative, cosine will be positive again, and for tan it will be negative again. And now let's get to the question. The question wants us to express cosine theta in terms of k. What they've given us is that sine theta is equal to k. So the first step is to draw a triangle, and we let this to be theta. And you know that sine theta is equal to opposite over hypotenuse. And they've given us that sine theta is equal to k, that's just k over 1. So in the triangle, that means that this side is k and this side is 1. And you can find the other side by using Pythagoras theorem, and that is square root of 1 minus k squared. So the question wants us to find cosine theta. Cosine theta is just adjacent over hypotenuse. And we can see from the triangle that the adjacent is square root of 1 minus k squared. Over 1. But we don't put it there because it's just over 1. But theta is obtuse. That means the theta is between 0 to 90 degrees. Between 90 degrees to 180 degrees. And from here we can see that for cosine, the sign is negative. So this is not our final answer. The final answer is that if theta is obtuse, well, since from the quadrant we can see it's negative, it's just the negative of this. And that's the final answer for that part. For the second part of the question, part II, they want us to find tan theta. Tan theta, as you can probably recall, it is opposite over adjacent, and opposite is k and the adjacent is square root 1 minus k squared. Alright, again this is not the final answer because we can see from the quadrant that when the angle is obtuse, the sign of the tan will be negative as well. So that means the final answer will be that tan theta, if theta is obtuse, minus k over square root of 1 minus k squared. And that's the final answer for that part. For the third part, now that's a bit tricky because you actually have to use some sort of double angle formula to find the final answer. So that is sine theta is equal to plus sine of theta plus pi, you expand it and it becomes sine theta cosine pi plus sine pi cosine theta. If you type sine pi into calculator, there's a 0, so cancel that part. The second part is nothing. This one is negative 1. So really sine theta plus pi is just minus sine theta. And you know that sine theta is already k, so that means that the final answer is just minus k. That's it. Really, there is question for question 1. So please follow me on the next video for the second question of this paper. Thank you for watching.